Welcome to part 2 of our functions video series. Now, in this video series, I'm just going to be expanding a little bit on what I introduced to you as what functions are. Now, when I was introducing to you the topic of functions, I said to you specifically, functions is nothing but a study of relationships, a relationship between x and y values. Now, I also said to you, between these x and y values, we are going to be having our rule. The rule can come in the form of a linear, which is the mx plus c, or it can come in the form of a quadratic, it can come in the form of exponential, it can come in the form of hyperbolic, and so forth, right? That's what I said to you, right? And then I also explained a little bit of how these input and output relationships are going to be working as we go forward, but I'm not going to get that deep into it. However, I need you to pay attention to this spider web. I know you guys are familiar with this spider web. I know you guys find this spider web ridiculously easy, so much so that your attention is likely to try and drift away right now. Bring it back and pay attention, because if you can understand the spider web, I promise you everything else will be squeaky easy, right? So according to this spider web, for every input we have an output. For every input we have an output. For every input we have an output. So for something to qualify then as a function, it needs to have that relationships, meaning when we are studying the relationship of functions, the relationship between the inputs and the output on a function, we are always and forever going to be looking for that relationship where we have an input. Let's look at graph A in this scenario here and graph B. Now, to give you a spoiler alert of a sort, graph A and graph B are functions. However, graph C is not a function. Graph C is not at all a function. It's not f of x. Graph C is not f of x. So, to illustrate what a function is, I'm going to be breaking down a little bit context of graph A. Let's look at this point in here. In this point on graph A, we have both x and y values at this coordinate. At this point, we have a corresponding x value in here. We have a corresponding y value in here. Meaning, at this point on the graph, we have one input and one output, which then is the same thing that we were saying in the spider web mouse, that for every input we need to have one output. For every output we need to have an input, right? So this then correlates with what we are seeing, what we are seeing in graph A. We can pick another point in graph A. Let's pick another random point in graph A. Let's say this point in here. In this point in here, we've got a corresponding input value as an corresponding x point. And then we've also got, by the same token, a corresponding y value, right? In here, there's a corresponding x value, there's a y value. X value, y value, hence it's a function. Graph B illustrates the same thing. In this point, you already know what I'm saying. In this point, I believe you already know what I'm saying. If you don't, please be sure to ask me to go dive deeper or at a slower pace in the comment section. Right, now I'm gonna go into graph C. Graph C is not a function. Why on earth is graph C not a function? I know some of you caught on what I almost said there. So this is why graph C is not a function. Graph C is not a function because here in this point we've got x as an input. The same input x value we have here is the same x value we have here, is the same x value we have here. So let's suppose for theory's sake that this x value in here is -3. When x is -3, y has a value of, maybe let's say this is 5 for simplicity's sake. Y can be 5. Also y can be 0. We know that y in here is 0 and y can have this point. So as such, this is not a function. So I believe this clarifies what, or denotes the distinction between what is a function and what is not a function. So thank you very much. I will be joining you in the next part where we'll be breaking down or getting into linear functions. See you in the next one.